Today we're going to be looking at the equation for a circle. A couple of things just to note. The center of the circle is called the origin, pretty easy, and it's drawn by a triangle all the way around the center. It's represented by, we're going to represent by the equation x squared plus y squared equals r squared. So similar to Pythagoras, a squared plus b squared equals c squared. And what it's kind of saying is, from the center of our circle, we can form a triangle from anywhere because the radius is always going to be the same. Pretty straightforward. So, our normal form, when we're looking at these particular circles, is going to be just what I had written. X squared plus y squared equals r squared. Now, what that looks like is, now I apologize for my dodgy diagrams. I'm probably not going to draw a very neat circle because I'm doing it freehand, but I'll do my best. So what that means for our diagram is our origin, or O, is going to be sitting in the middle. We're going to have a radius sitting off the side. Imagine a line coming down here forming a right angle. This here is going to be X. This height here is going to be Y, and we represent it by P, X, Y. So that's pretty much all this is saying, that our equation for our circle is x squared plus y squared equals r squared, meaning the radius is going to be the same length all the way around. So what can we actually do with that? Why do we need to know that? We might get a question that looks a little something like, let's have a little look. So we might get a question that looks something like, or it'll say sketch the graph, or sketch the circle, 4x squared plus 4y squared equals 25. That's our question up there. So sketch the graph, 4x squared plus 4y squared equals 25. What we want to do is get this in our Pythagoras form, essentially. So x squared plus y squared equals something. So what I'm going to do here is divide both sides by 4. If I divide this side by 4 here, I end up with x squared plus y squared equals 25 over 4. So I'm cooking with gas here. So I'm going to leave it as it is right now. The next thing I'm actually going to do is state the origin of our circle. Now, as we know, we haven't really mentioned anything about origin yet. If we have it in this form, x squared plus y squared equals something, it means our origin hasn't actually moved. We've not affected the origin at all. We're going to get to that a little bit later. So our origin for anything that looks like x squared plus y squared equals something is going to be 0, 0. Now I want to find out what my radius is going to be. To do that, all we do is let this side equal r squared, our radius, and we look at whatever we have left on this side, so 25 over 4, and we solve this equation. So if I square root both sides, get rid of this squared, square root of 25 is 5, square root of that is 2, so therefore r is going to equal, what, 2.5, 2.5? So we now have all the information we need to actually draw a circle. I'm going to do it on another whiteboard here. So I'm going to draw my Cartesian plane like this. Now you would do this with a ruler and you would measure. Running a 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we established the origin of our circle. Looking back at this, is going to be 0, 0. Let me just label this properly, x and y. So we established our origin is going to be 0, 0. So I'm going to mark my origin here at 0, 0. Okay, that's my origin. Now we know my radius, according to this, is going to be 2.5 units all the way around. So that means I'm going to 1, 2.5, 1, 2.5, 1, 2.5, 1, 2.5. Now, in theory, if this was all even and the world was perfect, if I connect all of these up, it's actually going to form my circle. It means any point here is going to be 2.5 units, no matter where I draw it from the origin of my circle. And I've pretty successfully drawn my circle. Now, we talked about the origin not moving, our origin staying at 0, 0. What we may get is questions in another form. And that form is something like this. X minus h squared plus y minus k squared, and it's going to equal r squared. So what this is saying is we have a translation on the x-axis, so it's going to move left or right, and a translation on the y-axis. That's all that is actually saying. So I'm going to have a little look at an example that looks something like this. X minus 2 squared plus y plus 3 squared equals 16. So if we have a look at this, this is actually saying if I was to solve for x, so let x minus 2 equals 0. If I was to solve for x equals 2, it's going to translate our circle, the origin of our circle, 2 units along, so 2 units to the right. Now if I look here, I solve for y, so y plus 3 equals 0, y equals negative 3, means it's going to translate my circle again 3 units down. So all I've done for solve for these values in here, h and k, which represent our translation. Okay, so that means our origin is going to be the values that we solve for up here. So our origin of our circle now is actually going to be 2 and negative 3. Okay, our radius, we work out the same. R squared is going to equal whatever's on the other side there. R squared equals 16. So that means R, take the square root of both sides, is going to equal 4. I now have enough information to draw my circle. So I have an origin of 2, negative 3, and a radius of 4. So, again, when I draw my circle, now you would do this accurately. I'm being quick and using a whiteboard. Not an excuse, but kind of an excuse. So x and y. Remember, my origin of my circle is going to be 2, negative 3. So if I went 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so 2 and negative 3. So my origin is going to be down here. It's not at 0 anymore. It's been moved because of these h and k values. So there's my origin. Now, my radius is going to be 4, so it's 3 down, so it means vertically it's going to be 1 there. It's going to be 1, 2, 3, sorry, 1, 2, 3, and 4. Another one there. Yeah, 1, 2, 3, and 4. So another one will be like down here. And 1, 2, 3, 4. And out from here, another one will be like there. So if I was to draw my circle now, drawing all of them up, it's a bit of a dodgy circle. But you get the idea. From this point, it's going to be 4. And each one of those is going to form a triangle as well. Okay, you would obviously label that. You would label your origin. You would label how far this point went to, how far this point went to. But I don't have the accuracy right now because I'm using these whiteboards. Now, there's one more kind of question that you get, which uses that same form that affects our origin. However, it gets a little bit trickier. You may find yourself getting a question that looks something like this. Sketch the circle x squared plus 2x plus y squared minus 6y plus 6 equals 0. This one looks pretty scary. It's not in a form that we recognize, but we do actually have a tactic we can use to get it to how we need to use it. Now we want to express this in our general form. So remember, our general form here is x minus h squared plus y minus k squared equals r squared. That's what we're actually looking for here. So if we have a little look at this, well, we can actually do something with this. And the thing we can do with these values is complete the square. So I'm going to complete the square on this x squared plus 2x and this y squared minus 6y. I'm going to complete the square on those. I'm not going to worry about the 6 too much right now. So let's look at this x squared plus 2x. So remember, to complete the square, we halve our value for b, and then we square it. So we halve our value for b, square it, then we add it to the end and take it straight away. So it's going to be x squared plus 2x. So if I half that and square it, it's going to equal 1. So there's my first little chunk of information. Then I'm going to minus whatever's left. Now I'm looking at the y squared minus 6 squared. So it is a plus y squared. I'm going to halve negative 6y and square it. So it becomes negative 3 squared. So negative 6y plus 9 minus 9 plus 6. And that's going to, apologize, I ran out of room, equals 0. So now I have this and I have this. So I'm going to do a couple of things here. I'm going to collect all of my like terms to start out. So I have negative, what have I got? Negative 9 plus 6 makes 3, negative 1, negative 4. Actually, let's look at this first. This can be rewritten as our perfect square, which will be x plus 1 squared. This can be written as a perfect square as well now. So we can go y minus 3 squared. Now all I've done is said what will add together to make 2 and multiply to get 1, and that's positive 1. Add together to get negative 6, but multiply to get 9, and that's negative 3. And now I'm going to collect these like terms. So I have negative 9 plus 6 makes negative 3, negative 4 equals 0. Still not quite looking like this, so I'm going to move my 4 over to the other side as a positive 4, and all of a sudden I have x plus 1 squared plus y minus 3 squared, and it's something I can start to work with. So now this is in our general form. So I'm just going to go over here at origin. Okay. Well, if we solve for x here, it would be negative 1, because x plus 1 equals 0. Move the 1 over makes negative 1. Then to solve for y here, it's actually going to be 3. So it's going to go over that way and up a little bit. And it's going to equal 4. So remember, to get our radius, and so it's going to be r squared. Let's make that 2 little dots. It's going to equal 4. So then I take the square root of both sides, so r is going to equal 2. I now have enough information to draw my circle. So we found that our origin was actually going to be at negative 1, 3. So I don't know, up here, so I probably should be a bit higher actually. Up here somewhere. Now we know our radius is going to be 2, so it's negative 1, so it means it's going to come out to about here, I don't know, here, here, and here. Now again, you would certainly be labeling all these units, and this point here, you may even want to label this point as 1, 3, just to show that you have gone out the correct number of units based on your radius. But again, if I draw from any point here, my radius will be 2, rotating around my origin. So looks messy, but all we really need to do is complete the square, do a little bit of rearranging, and then all of a sudden we find ourselves in general form. And from there we can get our origin, our radius, and then we can draw a pretty good approximation of our circle. And that's the equation of a circle.